Right, so we're going to have a look at question 3 from the exam paper 2016. This is from the chapter number 16, which is rates of reaction. Rates of reaction has a number of experiments. There's 3 experiments, I think, and they are all likely to come up as question 3 on the exam paper. So they all involve drawing a graph, because they're looking at the rate of the reaction, the speed of reaction. So, the graphs, you'd be given data and you would be to draw the graph. If we're looking at this specific question, we're looking at the decomposition of the decomposition of hydrogen peroxide to produce oxygen using the catalyst manganese dioxide. So they've done it a couple of times. They've done run A and run B, and they've given you all the values for the time and for the volumes at the various times. So they've asked you to draw a graph in part B. In part A, they've asked you to draw a labeled diagram. The label diagram, it says that could be used in either of the runs. Well, you're using the same equipment, so it's exactly the same. So just looking at your conical flask and maybe your dropping funnel, 8 marks going for the labeled diagram. So be sure and have your graduated cylinder there so that you can show that you're measuring the amount of oxygen that's coming off. Worth putting in maybe a stopwatch or something as well, because that's something that you needed to do this experiment, to calculate the time that had passed. And then the two reactants, so the reactants of hydrogen peroxide and manganese dioxide together in the conical flask. So that's for 8 marks. We're going to look at part B here, which is the drawing of the graph. So very important that you do it on graph paper. It says on graph paper. Use a pencil as well, and use a ruler. So be sure you have those pieces of equipment with you during the exam. So if we look at I've drawn the axis already. I've put time along the bottom, and I've got its units there as well. So we've gone up to 14 because our highest value is 12, and our volume I've put here on the y-axis. I've gone up to 90. Our highest value is 82, and again the units mentioned there with the volume as well. So if we look at run 0, 0 is the first point, so that's right there. Then we have 125, so that will be here. Then we have 241, Then we have 354, We have 572, We have 6.5 and 78. So 6.5 and 78, just around there. That's there actually. 8, 9, 10. The next one is 8 and 81. 8 and 81. And then the next one is 9.5 and 82. 82 is here and 9.5 is there. And then the next one is 11 and 82. 11 and 82. And then we have 12 and 82. So that's run A. What I like to do sometimes is just get a ruler to match up the points. Not too hard on the ruler, because you can turn these straight lines into a curve afterwards. But they can help with your curve drawing. So it's the upper point there. So if you make a mistake, do change it. That is a straight line there at the end. So that's run A. And as I said, you can turn this into a curve, freehand curve. The slope won't be awfully different. Just like that there. So in places, the curve does resemble a straight line. But in more places, it curves. So that is run A. And I'm just going to write run A there next to that one. The next one that we're going to do is run B. And again, we're going to plot the points. 0, 0 again is the first one. The next one is 1 and 16. 1 and 16. Then we have 2 and 28. 2 and 28. We have 3 and 39. Then we have 5 and 57. 57 is there. Then we have 6.5 and 68. 6.5 and 68. Then we have 8 and 76. 8 and 76. And we have 9.5 and 80. 9.5 and 80. And we have 11 and 82. So, and then we have 12 and 82. So the two last points are exactly the same as they were in run A. So again, just a little cheat here with the ruler for a start. Just lightly. Because you're drawing a curve, you shouldn't be using a ruler, but I find it helps. Just to give you a guide. I think there is equipment that you can get. I've seen it once. Equipment that you can get to draw a graph, to draw a curve. I'm not talking about a compass. No. So again, smooth off the graph. Just like that. Now, and we can label that run B. So, part B of question 3 is worth 18 marks, and you should get them all there for plotting the points, drawing the curve, labeling the axes, and making sure that it's all scaled correctly. On to part C then, calculate the instantaneous rate of reaction in centimeters cubed for run A at 4 minutes. So we're talking about run A, we're talking about 4 minutes. So I'm going to get my ruler, I'm going to go to 4 minutes, and I'm going to go up there to run A. So draw a line, doesn't matter if it's dotted or straight or if it's light or heavy. So that's where the 4 minutes hits the graph for run A. And when we're talking about instantaneous rate, we're talking about the tangent. So that we're talking about the tangent at this point here, essentially. So a tangent is a line that hits the graph in just one place. So you bring your ruler along and you see the point that you're talking about, and you want to get it hitting there, just at that point. And if you draw the tangent, then the longer the tangent you draw, the better, the more accurate it should be, because you get a wider variety of points that you can take as your to help you plot your slope. Then quite like the look of this point here, and another point would be this one here. Okay, so I'm just going to get some paper now. Paper's underneath. And we're going to write down those 2 points, and we're going to find the slope of the graph find the slope of the tangent, I should say. So you can still see the points there, I think. So if we're looking here, the first point, if we take first point being this one here, where we have this point here, our x value there is 6, and our y value is 82. Yeah, 82. So that's x and y, and that's our first point. If we look at another point, we picked this one here because it was a nice one to pick as well. 1 and 40. 1 and 40. So that's x and y there too. So what we're now going to do is we're going to look at the formula for calculating slope, which is m is equal to y2 minus y1 all over x2 minus x1. So you take one of these points to be x1 and y1, you take the other ones to be x2 and y2. Let's just keep it simple and put these as the x2 and y2, x1 and y1. So we'll have 82 minus 40 all over 6 minus 1. So here you get 42 divided by 5. And if we work that out, 42 divided by 5, we get a slope of 8.4. If we look at the range, they always allow a range for something like this. It's they are allowing any value between 8.2 and 9.5. So we've got 8.4, so that's ideal. That is perfect. Six marks for finding the instantaneous rate at 4 minutes in centimeters cubed of oxygen per minute. So that's the calculation, and that's the answer there for part D. C even, part C. If we're looking at part D, which run A or B reached completion first? That's just looking at the graph, and clearly you can see that run A reached completion. 82 was the maximum amount of oxygen that could be achieved. And which one had the slower initial rate? Well, the slower initial rate, again, you can see it from the graph here, run B. So the slope is less here in run B. So if we're looking at the answers for parts D, the first one is A and the second one is B. If we're looking at the rest of part D, this is again gone into theory. So what type of catalysis was involved in the reactions? Well, I suppose the type of catalysis that was used was heterogeneous, because you've got two substances in different phases. So you've got the hydrogen peroxide, which is a liquid, and the manganese for oxide catalyst, which is a solid. So because the catalyst is in the solid form and the reactant is in the liquid form, that is called heterogeneous. And then the last part, part D, suggests how the catalyst used in run A may have differed from that used in run B, and to account for your answers in part 1 and part 2. So you can see that run B is running slower, so there must be something different about it between B and A. So what else could it have been if it wasn't, or the same catalyst was used? So what about the catalyst might be different? Well, from the list of factors affecting the rate of reaction that surface area is something that will affect it. So perhaps the particles in run B were not as fine as they were in part A, in run A. Run A, they might have been more fine, there might have been a greater surface area, and then as a result, the speed of the reaction might have been faster. So that's one suggestion that would be possible.